Lesson 4.1, Prime Factorization. So we are gearing up to start getting to fractions, and before you can do that, you've got to talk about prime factorization. This is also a standard for iLearn. If you read what's in the box, it says a whole number is prime if it has exactly two factors, 1 and itself. So if nothing else goes into the number other than 1 and itself, it would be considered prime. I'll talk more about that in a minute. A whole number is composite if it is greater than 1 and has more than two factors. To determine the prime factorization of a number, use a factor tree. Do any of you remember doing a factor tree before?
Yeah.
Good, that's good. Now, I want to talk about primes for just a minute. Whole numbers begin with the set of 0, 1, 2, 3, and so on, ... Now, in order for it to be prime, it has to have exactly two factors. So 0 doesn't have exactly two factors.
2 does.
And 1 doesn't have exactly two factors. 1, how many factors does 1 have? 1. 1 is it. So 0 and 1 are neither prime nor composite. So prime, the smallest prime number is 2. Is 3 prime? How many things go into 3?
1 times 3.
1 times 3. So is 3 prime?
No. Yeah. Why not?
Yes. The definition of prime has exactly two factors, 1 in itself. What about 4?
Yeah. No.
It's composite because 1 and 4 go into 4, but what else? 2. So pretty much, could we say that if the number's even, it's going to be composite?
Yeah.
Every even number except which one?
2.
2. 2 is the only even number that's not composite. Okay, so we're going to go down to the examples. We're going to talk about a factor tree here in a minute, but let's talk about prime and composite. Let's look at some of these numbers. We'll look at the odd ones. So number 1 is 27. Can you think of any factors that go into 27? Brandon, anything go into 27?
1.
1. Yep. Anything else? Anything else, Brandon, go into 27? Four goes into 27. How many times? How many times does 4 go into 27 if you think 4 goes in there? Brandon, what's 4 times 6? What's 4 times 6? If 4 times 6 is 24 and 4 times 7 is 28, does 4 go into 27 then? Nope. Anything else go into 27? Can you think of anything else? Does 2 go into 27?
No.
No. Does 3 go into 27?
Yeah.
Oh, 3 goes into 27? How many times? How many times does 3 go into 27?
Many of the weeds. And I'll just work it out. Let the names work it out. You.
3 times what, Tyler?
9.
What?
9.
9. 3 times 9 is 27. So even the fact that I just knew that 3 was a factor, does that make that prime or composite?
Prime.
Does it make it prime? What's the definition of prime? What's it say?
I know.
Somebody want to tell us what the definition of prime was?
8 is a number that has exactly 2 factors.
Prime, Tyler says prime has exactly 2 factors. How many factors do we have listed up there with 27?
2.
4.
4.
So is it prime? No. So for 27, you would say that it is composite. And I'm going to let you write a P or a C. So that's composite. Okay, what about for number 3? It's 46. What could you say about 46? What do you think, Skip? It's divisible by 2, isn't it? Because it's even. So that means, is it prime or composite, Skip?
Prime.
So composite. Composite. All right, what about number 5? It says 11. What'll go into 11?
2.
2 goes into 11?
No. 1.
No. 1. Anything else go into 11?
11.
11. So only 2 factors. Prime or composite?
Prime.
Prime. And then what about number 7? It's 17. What about 17? Anything? What about 17?
Yes.
Kyler? 1 goes into 17. Anything else? 17. Anything else?
No.
Nope. So what's that make it, Kyler? Prime. Okay. So you're going to have to identify whether numbers are prime or composite. But the main focus of this is a factor tree. Now I want you to look at the example that's on the screen, example 2. It says, determine the prime factorization of 48. This is a factor tree. They start at the top with 48, and they start splitting it apart until they get to the bottom where the whole list of factors are prime numbers only. And your job is to write this with the correct number of exponents. And I think they've made a mistake because it says the prime factorization of 48 is 2 times 2 times 2 times 2 times 3. And then what exponent did they put on 2? Is that right?
No.
How many 2's did they use?
1 too many.
4. So it should be 2 to the 4th. And I want us to use dots. I'm kind of not a fan of using X's. 2 to the 4th times 3. And that's how you guys are going to write your answers, with exponents. That's our standard, just to write these with exponents. Let's try 64. And here's how we're going to do this. I'm going to start at the top with 64. And you can take a 2 out if you want, or you can take bigger numbers out if you want. I don't really care. And I believe as you go down this tree, when you come to a prime number, you should circle it so that you know that branch is finished. So 64, somebody tell me 2 factors of 64. Michael.
1 and 64.
Okay, we don't use 1 because it's not prime.
Okay.
So we don't need to use 1 because it's not prime.
8 and 64.
So 8 goes into 64, but how many times? 8 times what is 64?
8.
8 times 8. Now, is 8 a prime number?
Yes.
Yes?
No.
No. Which way is it?
No. Yes.
Okay, Brandon, prime only has 2 factors, 1 in itself. Does anything else go into 8 besides 1 and 8?
2.
2 does. So they're not prime. We need to keep going. So for this, I'm going to go 2 times 4 times, and then this 8, 2 times 4. Is 2 prime, did we say?
Yeah.
So every time you get to a prime, I want you to circle it. And that means that branch is done. Now, is 4 done? Can 4 break down? What can 4 break down to?
1.
Not 1. We don't use 1 in this. 2. So 2 times 2. And this 4 is 2 times 2. And we said all the 2's were prime. How many 2's are there total then? 6. So you're just going to write 2 to the 6th. Just like that. The answer is 2 to the 6th. What questions do you have? All right, let's go look at the next number. It says 45. 45. So let's start up at the top. Give me 2 numbers that branch off are factors of 45. Michael?
5 and 9.
5 times 9. Now, 5. Is 5 prime or composite? Can 5 break down any further? It's prime, so circle 5. What about 9? Can 9 break down?
Yes.
To what?
3.
3 times 3. Are 3's prime? Yes. So when we look at 45, what's the smallest factor then?
3.
How many times did we use it? 3 to the second times 5. 3 to the second times 5. Questions about that? So you're going to take the number, you're going to break it down until it's all factors of prime numbers. You're going to write the prime factorization. I would go ahead and use the lowest to the highest. Use exponents for the ones that are there multiple times. Does anybody have any questions?
Nope.
Potato chip.